Hello everyone, we have here an 11 mark exam question on coordinate geometry. So question 6, it says the straight line L has the equation 2y is equal to 3x add 5. The line L cuts the x-axis at the point A as shown in figure 2. And the first thing it wants us to do is to find out the gradient of L1. So in order to find the gradient of L1, what we need to do is we just need to rearrange it, okay? So we have our equation of L1 is 2y is equal to 3x add 5. So we're just going to rearrange this into the form y equals mx plus c by dividing by 2. So we have 3 over 2x add 5 over 2. So our gradient is 3 over 2. And that's our answer for A part 1. Now, part 2, write down the x coordinate of the point A. So the point A is the point at which the equation, the line with the equation y is equal to 2y is equal to 3x add 5, intersects the x-axis. And something intersects the x-axis at the point where y is 0. Okay, so for the second part, we need to say y is 0 in this equation. And that's going to give us 0 is equal to 3x add 5. And therefore, x is going to equal minus 5 over 3. So x is minus 5 over 3. And that's the second part of our question done. So that's 3 marks. Another straight line, L2, intersects L1, okay, at the point B with an x coordinate of 1, okay, and crosses the x-axis at the point C as shown in figure 2. Given that L2 is perpendicular to L1, find the equation for L2 in the form ax add by add c equals 0, where a, b, and c are integers, and this is worth 5 marks. So the first thing is we know that the gradient of L1 was 3 over 2. Okay, so that was our gradient of L1. So our gradient of L2 is going to be negative the reciprocal because they are perpendicular to each other. So the gradient of L, I've written m for gradient of L2 is going to be minus 2 over 3. So we've got its gradient. Now, what do we need to find the equation of a line? We need a gradient and we need a point on the line. And so how can we find a point on the line? Well, we're told that the x coordinate of B is 1. So whatever B is, we know it has an x coordinate of 1. But we know that it lies on the line L1, so we can use that to find the y coordinate. So when we sub into the equation of L1, we're just going to sub in there. We're going to sub in there the x coordinate of 1. So we have 2y is equal to 3 times by 1 add 5. So therefore y is equal to 8. 2y is equal to 8. So that gives us that y is equal to 4. Okay, so we know that B is now the point 1, 4, and we use the line L1 in order to find that. So we now have the gradient of L2, and we have a point on the line L2. So we can now find the equation of L2 by using y minus y1 equals mx minus x1. So y minus y1 is going to be y minus 4 is equal to the gradient, which is minus 2/3, and then x minus x1, which is going to be 1. We want it in the form ax add by add c equals 0. So we can times now everything by 3, giving us 3y minus 12 equals minus 2x, and that's going to be plus 2. If we get everything over one side, we end up with 2x plus 3y minus 14 is equal to 0. And that is our 5 marks done for part B now. Perfect. Let's move our attention now to part C. Find the exact area of the triangle ABC. So let's have a look. Now, this is interesting, and this often causes confusion for students. One of the first key things that we need to do in order to be able to find the area of this triangle is to understand that we essentially have the perpendicular height of this triangle, as I've just indicated on that sketch there. How do we have that? Well, we have that because we know the coordinate of the point B. We know that the coordinate of the point B is 1, 4. So therefore the y coordinate of B is 4. So in other words, the perpendicular height of this triangle is 4 there, which I'm just indicating on that sketch. So that's going to be super useful to us, the way that is 4. What else do we need to know? We could definitely do with also knowing what the length of the line segment is from A to C. Okay, so we definitely need to kind of work out what the length of the line segment is from A to C in order to be able to work out that triangle. So we already worked out earlier in the question what the coordinate of the point A was. So from earlier in the question, we know that the x coordinate at point A was shown. Write down the x coordinate of part A. We found out that that was minus 5 over 3. So minus 5 over 3, 0 is our point A. So now let's find out the point C. And all we need to do to find out the point C is go to our equation of L2 and sub in y equals 0. So our equation of L2 was 2x plus 3y minus 14 equals 0. And we're basically saying that y is equal to 0. So we have 2x plus 3 times nothing minus 14 equals 0. So this is to find out the point C. So therefore 2x is equal to 14, so x is equal to 7. So we've got the coordinate of the point C as 7, 0. So therefore we now have everything that we need in order to find the area of the triangle, because we have minus 5 over 3 here. We have that is 7 there, and we have a height of 4. So we're in a position now in order to be able to do what we need to do. And let's do that. So we're going to basically say that this is going to be 7 add 5 over 3. So we're going to have 7 add 5 over 3 is the length of our base, times by our height, which is 4. And then the whole thing is going to be a half, because the area of a triangle is a half base times height. Okay, so that is going to give us our expression for our area. And when we work that out, let's see what we get. We're going to find out that that gives us, I was just double checking that everything looks correct here, that gives us 52 over 3 as our area. And that's that question done. So that is a nice 11-mark question on coordinate geometry. I hope that you found that useful, and I will see you in the next video.